Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem number 29. Okay, fluid mechanics problem number 29. As usual, we first come towards statement. Okay, a uniform lead sphere and a uniform aluminum sphere have the same masses. Okay, dear students, this thing is very important, that have same masses. Okay, what is the ratio of the radius of the aluminum sphere to the radius of the lead sphere? Okay, dear students, problem is quite simple, very easy, very easy. What we have to do? Dear students, from the table of densities, we know the density of lead as well as the density of aluminum or aluminum. Okay, so it will be our base. Then we will come towards the point that volume of a sphere is 4 by 3 pi r cube. Actually, formula for calculating volume varies from geometrical shape to geometrical shape. Okay, here sphere is under consideration, so we will take the formula that will be applicable to sphere. Okay, so dear students, first we move towards the table of densities, in which we will find that density of lead and density of aluminum are so and so. Okay, this is table. Okay, yes, this is table of densities. Aluminum, left column, last row. Okay, aluminum density is 2.7 into 10 raised to the power 3 kilogram per meter cube. Okay, we will simply write it as 2700 kilogram per meter cube. Okay, now lead. Okay, lead 11.3 into 10 raised to the power 3, that is, we will write it simply as 11,300 kilogram per meter cube. Okay, so first thing has been done. Now we move towards the solution. Okay, we know that volume of a rectangular solid is equal to length into width into height. Okay, this is the most simple formula for calculating volume. Okay, which is applicable in case of a rectangular solid. Similarly, volume of a sphere is equal to 4 by 3 pi r cube, where r is the radius. Okay, and we know that the value of pi is 3.14, and it is its decimal representation is a non-terminating, non-repeating, it goes endlessly. Okay, and so and so. However, we do not go in such detail. Volume of a cylinder is equal to pi r square h. Similarly, volume of a cone is equal to 1 by 3 pi r square h. Okay, here, dear students, out of these four formulae, second one is our concerned formula. Okay, so we should not confuse other three formulae with this problem. Okay, other three formulae will be applicable in other problems. Now, as usual, we again start our problem in a formal manner. Density is mass per unit volume. If a mass m of homogeneous material has volume V, its density rho is given by rho is equal to m over V. Question number 1, we know from table of densities that density of lead, say rho L, where L is written as a subscript of rho, okay, is 11,300 kg per meter cube. Okay, and that of aluminum or aluminum, say rho A, where A is written as a subscript of rho, is 2700 kilogram per meter cube. Okay, we have taken these two values from table of densities. Okay, rearranging equation 1 as m equal to rho v and using volume equal to 4 by 3 pi r cube, equation number 1 takes the form as, what we will do, we will simply put the values and equation number 1 will take the form of equation number 2 and 3. Okay, equation number 2 is for lead and equation number 3 is for aluminum. Okay, here, dear students, as I had stated in the early part, in the starting part of this problem, that having same masses is very important in this problem. Okay, so dear students, equation equation number 2 and 3, which have developed or emerged from equation number 1 for lead and aluminum respectively, here, because both have equal masses, so we can say that left hand side of equation number 2 and 3 are equal. Okay, so when left hand side of these two equations are equal, then definitely right hand sides are also equal. So we apply this technique here. In case of masses being equal, this is equal to this. Okay, when left hand sides are equal, so right hand sides will again be equal. So in the next step, we have just simplified this expression. Okay, dear students, here actually kilogram per meter cube will be cancelled out from both sides. Okay, we can say that, we can justify this step by saying that multiplying both sides by m cube over kg. Okay, this term, this step, this act will eliminate kilogram per meter cube from both sides. Next, we justify our step by saying that we multiply both sides by 3 by 4. Okay, in this way 4 by 3 will also be eliminated from both sides. Next, we justify our step by saying that we divide both sides by pi, then pi will also be eliminated from both sides. Okay, hence this implies that we will be left with this form, that is radius of aluminum divided by radius of lead whole cube is equal to 4.185. Okay, okay, this implies that we take cube root of both sides. Okay, then we will get simply radius aluminum divided by radius lead equal to 1.61. Okay, so dear students, by taking cube roots on both sides, this 3 will be cancelled with 1 by 3, but cube root of 4.185 will become 1.61. Okay, so what is this? This is the ratio of the radius of the sphere of aluminium divided by radius of the sphere of lead. Okay, this is equal to 1.61. This is greater than 1. When this is greater than 1, then this indicates that numerator is greater and denominator is smaller. Okay, so this implies, what implies? This greater than unity fact. This implies that aluminum sphere is larger since ratio is greater than 1. Okay, this was to be answered and we have successfully reached the conclusion. This table we have already discussed, this table which was only for densities of lead and aluminum. Okay, now we come towards the reference. Okay, dear students, in my previous module, that is problem number 28, in the last part of that module, Adhan had started, and so I had verbally given an expression to leave this video. Okay, but here Adhan is not going on, so I read this reference completely. Reference book is Sears and Zemanski's University Physics with Modern Physics. Its authors are Hug D. Young, Roger A. Friedman, A. Lewis Ford. Its publisher is Pearson, and its 14th edition having been published in 2016 or 15th edition having been published in 2020 has been adopted or followed. Here chapter number 12 under title Fluid Mechanics is our concerned chapter, and this problem is enumerated at serial number 5 of the exercise given at the end of this chapter, that is exercise number 12.5. okay, that is fifth problem of 12th chapter, and this is the end of our module, our problem. Okay.